take it anymore. Where was I? Hey guys, it's Eddie the Grouch. And for this little quick episode, well, maybe it is going to be quick, maybe not. I want to talk about carbide insert tooling. Now, there is a big raging debate of, or actually probably a lot of confusion. Do I, should I, can I run carbide insert tooling or any insert tooling with my small lathe? Now, I'm addressing all you small machine owners like myself. I run a even though it's a larger bench top, it's pretty much a bench top machine. While it's not the smallest of the classes, there are probably a couple of X2 minis that are actually a little smaller than mine. Mine shares many of the same traits, meaning rigidity and I guess rigidity. Pretty much that's it. In machining, it's all about rigidity and precision. And you really can't have one without the other, because we're shaping metal, and metal fights back. So you need to have something, a little mass in the ass to take up the shocks and to force your way into the metal to shape it the way you want it. Anyway, for people with my class and lower of machine, should we use carbide tooling? So let's look at some of it, because my project today was started out to be making a tool holder like this. And that's just setting the stage. We'll get back to that in a second. But let's look a little bit at some carbide. I'm going to zoom in to the desktop there. Okay, now we're going to look at some pieces of the carbide and what you should look for, because chances are, if you've used carbide tooling before, it was probably given to you by a friend, or you just picked some up at random, not realizing there is a wide difference between them. Now, for a smaller machine, you want what's called a positive rake. Just like your high-speed steel tooling, you're going to want something with a good rake to it, a good attack angle, something that's really going to bite into it. And this here is this is an insert particularly well suited for aluminum. This is pretty close to these, which I did buy for aluminum, hence the AL designation there. And you can see this is a single-sided insert. Look on the bottom, there is nada. On the top, you have this wicked rake there. Nice high rise, deep attack rake. Nice smooth surface, because aluminum likes to dig in and grab onto shit. It's like it fights its way out the door. And this is about a 7-degree relief angle on the nose. So this is a really good tool, and they leave a beautiful finish, and these can be run with most machines, or all machines, because of the high angle, high rake, smooth tool. It takes very little tool pressure for this thing to do its job. And these are just nice to have around, because I do a lot of aluminum work, and they do leave a beautiful finish. And these aren't I can't even see these were expensive. I picked these up probably for 30 bucks. I think it was about that shipped to the door. And that's 10 inserts, and they do work nicely. But in my rambling way, let's get back to the different styles now. This would be an example of another positive rake insert, single-sided. It's got a deep rake on there that could be probably more than a 7, maybe 8 or 10. It's more of a dish shape on the top, but this does count as a positive rake tool. And that will cut probably steel pretty nicely. This is more or less like that one. This is another single-sided, and that has a positive rake on it with even a flatter dish on the top, but still should cut some mild steel pretty nicely. And this one's probably the least offensive of them. This is a I got all these at the junkyard, so I don't even have the numbers on them, but by looking at it, I can see this does have a slight bit of rake on there, probably a 3-degree, and it's got a little bit of positive on the front, and this is all chip breaker here, and this would be good for steel. These examples here are double-sided, and chances are you probably tried these on your small machine, and that's probably where your issues arise. A double-sided insert is going to have no relief, just because that's the way they're manufactured. So you're going to have a zero relief. Now the only way you can get a relief is by using a tool holder that angles the tool bit down just a little bit. I believe I have somewhat of an example, but I do have the wrong tool in there. I have a tool that already has a rake in it, but that's kind of why I'm building the new tool holder. This one I made for these style inserts, and if you can see the line there going across, you can see how the tip angles downward to the cutting edge. And this one's approximately 5 degrees, and that is the only way that a double-sided insert can provide any relief. It's done by the tool holder itself. Boy, I cranked that sucker on there, didn't I? I'm glad I experimented this way before buying a bunch of this stuff, because it would have worked pretty dismally on my machine. The only use I really found good for is blasting off scale and snot, but it really takes a lot of tool pressure and some grunt on the machine in order to get a good cut on metal with this kind of stuff. Okay, you see there's the flat, the zero angle on these inserts, so it gets that teensy bit of relief by angling the whole insert downward and giving you the clearance at the very nose. Now the problem with that is, once you've angled the bit down, that doesn't leave you a whole lot of room and ability to put rake on the top hand side where you're actually doing the cutting, so it's going to be limited. So if you want to use this kind of stuff on a smaller machine, you're going to want positive rake inserts, single-sided. And the good rule of thumb is grab one. If it's sharp to your finger, it'll be sharp to the metal. If it's dull to your finger, you know, it's like trying to cut steel with a butter knife. It's just not going to work. So if this is what you played with before, take another look at insert tooling and get something more suitable to your machine. Now, how do you know what is more suitable for you? Well, I happen to download some of these pages here from a place called Carbide Depot, and they have some nice little reference material on here. And we look at the designations. So I'm going to use this type as an example. These are the CCGTs. Now, along with a lot of other people, I thought the G stand for a ground finish. Well, it just happens to work out that way a lot, but that is actually a fallacy. But let's go down the line. First letter designation. Mine's a C. A C is going to be the 80-degree diamond, and that relates to the whole shape of the insert. So this here is a square, so that's going to be an S. That's an S insert. There's no parallelism to it. It's just a square. And I don't know what I'd use that for. I don't have a square tool holder. You got your triangles. That should be an easy one. That's a T. Like a TNMG. Blah, blah, blah. It's a very popular insert. And these should be so popular that you can get these in a positive rake. There's another big square. We got, I have some narrow rhombas and stuff, but I call them. The V is a good choice for like profiling. Get that narrow diamond shape. But anyway, let's move on to the next letter. So we got the CCGT. Next C is 7 degrees. That is a 7-degree clearance or relief angle, and that is this angle here from the tip downwards to the bottom of the insert. So that is the angle that the tip is being presented to the workpiece. Now if I put it in a 0 degree or an N tool holder like I showed you here, that makes this even more of an angle. So we got 5 degrees plus the 7, so that's a 12 degree. But when you do that, you're losing some of the shearing action on the top, so it provides a flatter face to the workpiece and the metal, and it doesn't want to shear off as good as it would if it was at its flat normal angle like this. So it's not really suitable to be used in those tools. It can be used, and you'll probably get more success using this type of bit in this type of holder But let's just say if you're running a small machine, you want to stay away from these N style holders. And the fun part is, if you're a machinist or tinkering, you should be making your own holders anyway, which is what I'm going to do. And since you don't have to mess with that angle, all you have to do is cut the sides and the hole. You're groovy. So we don't have to worry about that compound 5-degree angle. And that was a pain in the ass. So now I'm getting away from all that. I still like to use high-speed steel, but it's nice to be able to just grab a point and go when you're in the middle of something. Or have something with a predictable nose radius if you're trying to do half-assed CNC like I am. Moving on. I know I'm horrible at jumping around. The third letter, shown by that little thing there, is mine's a G. Now see, G does not stand for ground. It stands for the tolerance. And the most popular, which is an M, you can see according to this chart, is next to the last of the sloppiest tolerance tools. And that's how they keep the cost down. People use these inserts because, especially on manual machines, it doesn't matter. Once it's loaded in the tool, you're touching off and doing all that stuff anyway. This would more come into play when you're running CNC, and you drop that tool in your old holder, and you want your tool table to be correct. So if you really care about that, you're going to get a better designation like the AACs or such to line up with the old. It'll be more consistent when you're higher letters, sort of like bearings. You know, your higher precision bearings are going to be more persistent with those letter designations. But the popular M, well, that's good for manual, but not what I needed for. Actually, it doesn't matter for me because I touch off also on my CNC. But no, it doesn't stand for ground. It stands for the tolerance of the overall shape as far as the radius, the height, the width, and blah blah blah. So any of these will work for you. That's not a deal breaker when you're picking out your stuff. And the fourth letter is the hole chip breaker combination. Now mine is a T, and that tells me right there it's a single-sided, a double countersink, and that just stands for the type of screw profile it has in here to tighten it down. Some of these, like this one's going to be, see, it's got a single countersink and it's a straight hole. Pretty much use a pan head on that. But it would take a certain type and size of screw to hold that snug. This would be probably an F, maybe. Oh, excuse me, not an F. No. Could be a P. But either way, this has a slight chip breaker in here, but it's still very dull to the finger. So it's not something I would use on a small machine. Either way, that's pretty much your letters. Grab these sheets. Go to Carbide Depot, look in the reference section, and grab you this stuff because it's going to be a big help to you when you go on eBay looking for some inserts to try out. You'll have an educated guess of what you're getting and what it means. Or if you find a wonderful sale that looks too good to be true, and you look up the numbers and you find out they're totally unsuitable for your machine, that's going to be it. So size and shapes, not a big deal. The big thing is your clearance and relief angles. You don't want to do the ends. Stay away from end. If you have a slightly bigger machine, you can use probably A and all the way down. For the smaller guys, you probably want to stay with the C's and up, because that higher relief angle means higher pressure at the very cutting point of the bit. So the higher that is, the higher that clearance angle, the more power to a point, so to speak, and you can really dig in and cut some metal. And for aluminum, look at that's some high rake stuff there. You're not going to, a lot of this, you ain't going to see these letters until you probably hit to mill tools and such, but except mine's a 7 degree and it works just fine on aluminum. For steel and such, I'd probably use 3 and 5. The end would be just like using a well, actually it wouldn't be like using anything. Stay away from end. Small machines, stay away from end. That's all I'm going to do. Now I realize I'm making a sweeping generalization or a blanket statement to avoid the negative rake tooling for small machines. But that's because they really don't have the horsepower or the rigidity to function the way they are intended to do. That type of tooling not only cuts, but it also forms the metal, and it does this by using a high tool pressure and a high speed to run the metal against that blunt edge of the tip. And as it's doing that, the metal is being heated up, it's being deformed to the point of fracturing, and then it breaks or cuts off, and then the smooth edge of the tool kind of burnishes it back into place, and you get a smooth finish. And it's almost a different cutting action as you would get with like an aluminum bit or a standard high rake bit on a smaller machine. So since your machine really can't do that kind of cutting action the way it's intended, that's why you kind of just want to avoid that altogether, and that's why I said that. Blah 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 blah, and this has to do with what type of screw style it's going to be. So if you happen to get a holder for the tool, you got to make sure that your hole size takes the right kind of screw that's going to hold down your tip. But if you're making your own, you're probably winging it just like I am. In fact, this is just a little stainless steel screw that I got out of the crap pack from the hardware store, and I just turned it down to give me a decent profile to fit into my particular aluminum style inserts. See, nothing wrong with that. It won't get in the way of the chips, and it's got enough threads and meat there to give it a good grab. So that's what I'm going to be using. So hole size really doesn't matter. This just happens to be what I grabbed, and since I'm making a tool holder, I will make a screw to fit. But grab these references. They're very handy. Back to my tool holder. That was just a bunch of aside stuff. This is what I'm going to try to make. I'm going to make it if it kills somebody. This is what's known as an SCLCR. What the hell does that mean? Well, you can get another chart. This is for this particular shape, which is an 80-degree diamond right here, which is very popular. And the S stands for screw lock, which means it takes a screw to hold it down. It's not the clamp style. It's not a pin style. It's not the pin and clamp style. It's a screw. See? Screw. The insert shape. That's the important one there. Not square. It's going to be a C. 80-degree diamond. As you can see, that is going to fit in there just like that. The L is a tool holder style. My L is 5-degree side and end cut offset shank. And what is that? That is this little bit of angle right here. So if this line here, if we call that a 0, and if we write it in with a pen, which I don't have because I took it in the house, but we'll just count that as our 0 degree line there. Well, this piece here is going to be 5 degrees different, so that'll be 5 degrees going this direction. I'm just going to have to use one of these. This is SCLCR. S is for screw lock. That has a hole, so that's going to be locked down with a screw. The insert shape, C, which stands for the 80-degree diamond, which is what that is. That means there's an included angle of 80 degrees on that point. And on this particular point, I believe it's 100 degrees. So you work out 80, 100, 80, 100, blah, 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 you get 360. And these are nice because unlike a square tool, if you use this particular style of tool holder and you have your tool holder locked like this facing your workpiece, you can both face and cut without having to change the orientation of the tool. That's what makes it popular. So this is a good all-purpose must-have style of tool for anybody with a lathe. The L, which is the tool holder style, this particular one has a 5-degree offset. So it's going to be 5 degrees off. This direction here is going to be 5 degrees off from that. And here it's going to be 5 degrees off from here. Five degree difference, which lines up with the cutting points on this, because you want just to be just balanced to where you have both relief, you have relief in both directions, either facing or turning. And then the other 5 degrees, because we have 80, and 90 degrees is our straight corner like this. So now that we're dealing with 80, we have 10 degrees left over. So 5 is being used on one side, 5 is being used on the other side. So your pocket is also going to be 5 degrees off, except in the other way. So from my 0 point on the machine, when I start milling it, I'm just going to have this set as my 90 and this is my 0, and I'm just going to go 5 degrees off of those edges to give me the shape of my pocket. And then the depth will just run it in there and clean it up afterwards. So I'm going to start with the very hardest part for me is going to be the pocket itself. Once I have that established and comfortable with that, then I'll go ahead and cut the bar, machine this. I'll take away some metal here so I have more relief room, and do the reliefs on the sides. And since this is a positive rake tool, single-sided, I don't have to do a compound angle on the pad. Groovy, groovy. Now I'm going to tell you now, I am going to cheat, because this is a positive rake insert. The sidewalls are not 90 degrees. So when it sits in the tool, it's only going to contact a very small portion or be loose. And if you have the pocket real deep, you have a chance of breaking off the edges or the tips and stuff. So my plan is to machine it just a little bit on the sloppy side as far as wall spacing, and then I'm going to pack that in with JB weld and probably a saran wrap, or I'll coat this with some release agent, and I'm going to put that right in there and let it sit that in that pocket screwed down and let the glue form around it. And then I will have a good all pressure holding on this particular bit. See the plan? I know I explained it bad. I'm really horrible. It comes with dementia. I'm getting old. It's setting in. I can't think straight anymore. So I'm doing this while I still can. That's the plan. I'm going to start making this tool. And how am I going to do that? I will show you. Because if I can do it, anybody can. If Eddie the Grouch can make something, there is no excuse for you all not doing it too. So what I have here is, I got the crappy rotary table, which I'm trying to get some use out of. I got my vise on top of that, since all I have are particular for T-nuts for this unit is only 1/4 inch, and I couldn't think I could get a good grip on a bar trying to clamp that down with 1/4 inch all thread. So I have just enough room to stack the vise on top of that, and then the bar is in the vise. So I think I've got it held down good enough to mill with. And this is just hanging out because I said I'm not cutting the bar until I've actually got this part done, because if I screw up this pocket, I can lop that off and start again rather than having an extra 4 inches that I'm screwed with. See what I mean? So I've already dialed this in to be true with the movement of the axis on the table. So now I'm going to count that as my 0 or 90. Either way, I'm good to go. So I'm going to pick out a suitable, well, actually I can reset this bar here because I don't want overhang. I'd like to have a good hold on that. There. Because my first operation is I'm going to take this nose of metal down. Now this is a 1/2 inch thick piece of steel here, and I'm using an AXA tool holder, maximum 1/2 inch. And since it already has to sit high up on my compound, any tool that's at the 1/2 inch mark will not line up to center of my work on the lathe. So I need to drop this down and then put a pocket in, so the tool tip itself, remember these high rake bits look deceptive because the actual tool tip sits way up there, right? So I need to take this down about a couple of 16ths, and then I'll put a pocket in so my bit will actually sit probably about that height. Make sense? I hope so.